Math with Mr. Williams, Example 1, Finding a Line of Fit. The table shows the number of absences in a school year and the final exam scores for several students. Make a scatter plot of the data and draw a line of fit. Write an equation of the line of fit. Interpret the slope and y-intercept of the line of fit. Okay, let's start off with finding an ordered pair list. So we see that we have a table here. We have absences x, final exam score y. We know that that's in format x, y when we go to make your ordered pairs. So therefore, everything down this list can be turned to an ordered pair. 097, 388, 293, and so on. Now let's go ahead and plot those on our graph. So the first one's up is 097. Then we have 388. We have 293. We have 583. We have 773, 970, 588, 194, 965, and lastly 873. Now we made our scatter plot. Let's go ahead and draw a line that's close to the data points. Okay, this can be called our line of fit. You try to have as many points above the line as below the line and try to go through as many as possible. Okay, since our line basically goes through 388 and 873, we're going to use those to help us distinguish the slope. Okay, let's plug our numbers in. So we see the y2 is going to be a 73 minus y1 was 88. We're dividing by the x2, so 8 minus x1 is 3. We have 73 minus 88. That gives us a negative 15 over 8 minus 3 is 5. We simplify and we end up with a negative 3 for our slope. Right, to find our y-intercept, you know there is a dot generally at that 0.97, which is really easy to tell. We can go ahead and plug some numbers in an equation, and we'll use 388 to do it. So my y value will be 88. My slope will be negative 3. My x value will be 3. And then I'm just looking for the b. So in this case, we have 88 equals negative 9 plus b. Let's go ahead and cancel out the negative 9 there. So we're going to add 9 to both sides, giving us 97 for our y-intercept. We have our slope, we have our y-intercept, and let's rewrite our equation, including the slope and y-intercept. Okay, for C, it says, interpret the slope and the y-intercept of the line of fit. The slope is negative 3, and the y-intercept is 97. So a student with 0 absences is expected to earn 97 on the exam. So the score decreases by about 3 points for every absence because of the slope being negative 3. Math with Mr. Williams, Example 2. Finding a line of fit. The table shows the total number Y in millions of subscribers to a video sharing website X years since 2010. Write an equation that models the total number of subscribers as a function of the number of years since 2010. 2. Interpret the slope and y-intercept of the line of fit. Let's go ahead and start off by making a line of fit based on the graph that's presented. We can do this because it has a positive linear correlation. Okay, to find the slope, we're going to pick the 2 points presented. We have 226 and 776. Let's substitute our numbers into the slope formula. 76 minus 26 will give us 50. 7 minus 2 is 5. 50 divided by 5 is 10. So our slope is 10. Now to find the y-intercept, we just write down our equation. Substitute what we know in. I like to use the first point given. So 10 times 2 is 20. Now to remove the 20, we need to use inverse operations, so we're going to go ahead and cancel it by subtracting 20, giving us 6 equals the b, or the y-intercept. So we go back to rewrite our equation. We write y equals, our slope is 10 times the x plus 6 for our y-intercept for our equation. So what that means is, in 2010, which was represented by 0 on our graph, we had about 6 million subscribers, and the number of subscribers increased by 10 million each year.